Good morning, good afternoon, good evening. Welcome to Max Makes Maths Easy. Today we are going to do a question on integration. Today we are going to do a question on this is a calculus, and our question is integration. Remember, calculus entails differentiation and integration. I told you we will be looking at an integration question. So our question is integrate 1 over 1 plus x cubed. So remember here, you must be aware of the techniques of integration. Your integration techniques must be good. So to do this question, you must know the technique that requires you to do integration by partial fractions. And when I say partial fractions, I mean there must be decomposition of the polynomials given. Let's say you're given 1. Remember, these are a polynomial of degree 0. This is a polynomial of degree 0, and 1 plus x cubed is a polynomial of degree 3. It's a polynomial of degree 3. And remember, from your algebra, that's linear algebra, this can be written as the integral of 1 plus 1 over x cubed plus 1. Here I've not changed anything. And also here, you must know how to do this can also be written as, you must know how to do, you say addition of cubes. Remember, this is the same as saying x cubed plus 1 cubed. See, even here I've not changed anything. And if it is an addition of cubes, this means that I have the integral of 1 all over x plus 1 into x squared minus x then plus 1. Even here I've not changed anything. So remember, here I've just said 1 over 1 plus x cubed is the same as the integral of 1 over x cubed plus 1. I have not changed anything. And here also I've said 1 over x cubed plus 1 cubed. I have not changed anything. And this x cubed plus 1 can be written as from your linear algebra, it can be written as x plus 1 into x squared minus x plus 1. So if you want to integrate this, remember, our final integration becomes 1 all over x plus 1 into x squared minus x plus 1. So stick around. We're going to do this question up to the end, so stick around. And if there's a part you can tell you to do, then you give me the answer. So let's continue. Remember, if I want to do this integration, this integration can be done because this is an irreducible quadratic. This is an irreducible quadratic over here. This is an irreducible quadratic. And what did we say about irreducible quadratic? Irreducible quadratic can be written as, if this cannot be reduced, that's what we mean. It can be written as, to find the integral, it can be written as a over x plus 1, then plus b x plus c over x squared minus x plus 1. This is the same as this integral. I hope you have understood. This is an irreducible quadratic, so it can be written as a over x plus 1 plus the integral of bx plus c over x squared minus x plus 1. So the task we have here is to find the values. The task we have is find the values of a, find the values of a, b, and c. We have a task of finding the values of a, b, and c. And how will we find the values of a, b, and c? We'll find the values of a, b, and c by saying, remember I told you this we can compare this with this. So how will we compare this and this? So we say we take this one, divide by this, and then multiply here. Then we will equate it to the top, which is 1. So we will say x plus 1 goes here. How many times it goes here? X plus 1 times. So we're going to take this, it goes here, x squared minus x plus 1 times. So we're going to take this, then we multiply it by m. That will be a into x squared minus x plus 1. Then we say plus, how many times that does this goes here? It goes here, x plus 1 times. So we are going to say x plus 1, then we multiply it by bx plus c, then we equal it to this. So even here we will say how many times that this goes here. It goes here 1 times. So we're going to take 1 multiplied by 1, then we equate it to 1. I hope you have understood there. So what we're going to do, we're going to open the brackets. So when we open the brackets, this becomes ax squared minus ax plus a, then plus x into bx plus c, then 1 into bx plus c. This is equal to 1. Then ax squared minus ax plus a plus bx squared plus cx, then plus bx, then plus c, it's equal to 1. So we are going to put the like terms together. So we are going to say x squared plus bx squared over here, then minus ax, then plus cx, then plus bx, then we say plus a plus c is equal to 1. So what we're going to do next is put the like terms together. So it will be a plus b x squared plus minus a plus c plus b x, then plus a plus c is equals to 1. Then we are going to equate. Remember here we have this is a constant term, where if we have x squared on this side, we don't have an x squared on this side. So we will say a plus b is equal to 0, then minus a plus c plus b, it's also equal to 0. But remember here there is a constant term, which is a plus c is equal to 1. A plus c is equal to 1. So we have 3 equations. that will help us to find the values of a, b, and c. We have 3 questions that will help us to find the values of a, b, and c. So from our first equation, from equation 1, a is equals to minus b. From equation 1, a is equals to minus b. A is equals to minus b. And from our third equation, remember we said a is equals to minus b. So we can replace here a. So since we have from 3 is equals to a plus c is equals to 1, we can say minus b plus c is equals to 1. Then c will be 1 plus b. C will be 1 plus b. From there we will replace c in equation 2. So we will say minus a plus 1 plus b is equal to 0. Then we'll say minus a plus 1 plus 2b is equals to 0. Then minus a plus 2b is equals to minus 1. So remember we have this equation, let us call it equation 4, and we have equation 1 over here, which is a plus b is equals to 0. So from here we can eliminate either a or b to find the value of b. We are going to find the value of b. We are going to add here a, then it will be minus a plus a, that will be 0. Then 2b plus b, that will be 3b. Then minus 1 plus 0, that will be minus 1. Then we will find our b as minus 1 over 3. Our b, we will find it as minus 1 over 3. And remember we said a is equals to minus b. Since we find our b as minus 3, then our a is equals to minus 1 over 3, and our a becomes 1 over 3. So we have a task to find our c, and we will use equation 3. From equation 3, we said a plus c is equals to 1. So it is same as 1 over 3 plus c is equals to 1. Then our c is equals to 1 minus 1 over 3, where our c will be 2 all over 3. Our c will be 2 all over 3. So we have our a as 1 over 3, our b as negative 1 over 3, and our c as 2 over 3. So what are we going to do next after doing that? So we are going to say our question simplifies to, we said it simplifies to a over x plus 1 plus the integral of bx plus c over x squared minus x plus 1. Since you have found the values of a, b, and c, we are going to replace, and it will be the integral of 1 over 3 over x plus 1 plus the integral of b, we said is negative 1 over 3x plus c, which is 2 all over 3 over x squared minus x plus 1. So what do we mean here? We mean we can pull out the 1 over 3. So 1 over 3, the integral of 1 over x plus 1 Then we pull out our negative so that we can remain with x here. So it will be negative 1 over 3, the integral over x, then minus, if we pull negative 1, we pull the negative 1 over 3 and we want to remain with 2 over 3. If we return it, it will be minus 2 over x squared minus x plus 1. So all this integral over here simplifies to the integral of this. Remember, if you want to find the integral of this fraction over here, we said we can use the natural logarithm to find the integral if the derivative of the denominator is equal to the polynomial we have at the numerator. So this, since the derivative of x plus 1 is 1, which we have in the numerator, we can say this simplifies to 1 over 3 natural logarithm of the absolute value of x plus 1. Then what do we have here? Since we have the derivative of this is 2x minus 1, which is not equal to x minus 2, we have the task of finding this integral over here. So when do we use the natural logarithm? We use the natural logarithm as the integral when the derivative of the denominator is equal to the number we have in our numerator. So we have a task to find this integral over here, since you have already finished to find the integral of this part over here. So we are remained with it. So we will do like this. We will say 1 over 3 ln natural logarithm of the absolute value of x plus 1 minus 1 over 3. Then we are left to do the integral of x minus 2, x squared minus x plus 1. So we are left to do this integral, then we will multiply it by negative 1 over 3. Then we do the subtraction. So we are left to do the integral of x minus 2 divided by x squared minus x plus 1. Remember what I told you here. I said you can only use the natural logarithm when the derivative of the denominator is what we have on the top. So the derivative of the denominator, which is x squared minus x plus 1, is 2x minus 1, and on top we have x minus 2. So what are we going to do? We are going to make our numerator to be the derivative of the denominator. So what are we saying here? We are saying this integral over here simplifies to, what can we do on the numerator to make it same as then, to find the derivative of the denominator. So what if we multiply 2 here? See, it has become 2x minus 4. 2x minus 4. That becomes 2x minus 4. What if we divide by 2? So if we divide by 2, we have not changed anything. Since this 2 will go with this, then this becomes 2x minus 4. So this will simplify to 2x minus 4 divided by 2. 2x minus 4 then divided by 2. So this also means 2x, since we wanted 2x minus 1, which was our derivative of the denominator, we will say 2x, this is equal to 2x minus 1 minus 3 divided by 2. So this over here, this x minus 2 can be written as a 2x minus 1 minus 3 over 2. So this integral becomes 2x minus 1 minus 3 over 2, then divided by x squared minus x plus 1. Hope you have understood. 2x minus 1 minus 3 minus 3. And what does this become? Since we wanted this to be 2x minus 1, we will say this becomes 2x minus 1 2x minus 1 divided by 2 minus 3 over 2 divided by x squared minus x plus 1. Remember, I've not changed anything over here. This is the same. Since I want here to be 2x minus 1, I will say if I take remember here also this, if I decompose this one, I will say this is equal to the integral of 2x minus 1 over 2 over x squared minus x plus 1, then minus 3 over 2 over x squared minus x plus 1. So when we come to the next page here, I hope you have understood the next page here. So I will factor out a half. So this is the same as the integral over a half into 2x minus 1 over x squared minus x plus 1 minus 3 over 2 into 1 over x squared minus x plus 1 over there. So what do I mean here? I mean this becomes a half into 2x minus 1 divided by x squared minus x plus 1 minus 3 over 2 integral of 1 over x squared minus x plus 1. Remember what I said? What I said is you can only use the natural logarithm if the derivative of the denominator is equal to the polynomial we have on our numerator. So the derivative of this one is 2x minus 1, which we have here. So this becomes a half natural logarithm of the absolute value of what we have in our denominator, then minus 3 over 2 the integral of 1 over x squared minus x plus 1. So this becomes, remember here we said we will multiply negative 1 over 3 on what we find here. So remember we are left with the task of finding the integral of this. So the answer becomes a third natural, from here a third natural logarithm over x plus 1, then there's a negative 1 over 3 over here, then into a half natural logarithm over the absolute value of x squared minus x plus 1, then we minus 3 over 2 the integral of 1 over x squared minus x plus 1. So this becomes 1 over 3 the natural logarithm of x plus 1 the absolute value, then minus 1 over 3 times 1 over 2, that becomes 1 over 6 the natural logarithm of the absolute value of x squared minus x plus 1, then minus 1 over 3 multiplied by minus 3 over 2 the integral of 1 into x squared minus x plus 1. So what we are left to do is this integral over here, then we multiply by negative 1 over 3 and our answer becomes complete. So what I want you to do, or what we will do in our next video, is find the value of the integral over here, or if you have time, find the integral over here, following all the steps by partial fractions with all the techniques you know of integration. Try and find the integral of this negative. You are only doing the integral over 1 over x squared minus x plus 1. Then you will multiply it by negative 3 over 2, then multiply it again by negative 1 over 3. So this is the task I want you to do. If you have been following, kindly show your support, and welcome to Max Makes Maths Easy. Thank you very much, and we have been doing integration. Welcome.